Okay, so now that we know a little bit about derivatives, we have some class examples here. Starting with class example 1, it gives us, let x of t denote the position in meters of a particle t seconds after it begins moving. Determine the position, the velocity, the acceleration of a particle at time t if 3 different scenarios. 1, x of t is this polynomial. 2, x of t is a sine wave. And 3, x of t is actually a combination of a cosine wave and a polynomial. So let's see how that would work and use our rules on that. We set up our example. We're given these 3 functions, that x of t is the position at a time t in meters, t is the time in seconds. We're required to determine the velocity at time t in meters per second and the acceleration at time t, which will end up being in meters per second squared. Okay, and so we know that the position function given for part A, that the velocity is the derivative of that function. And I've already written things down incorrectly here. This is a cubed, which makes this cubed and this squared. So let me correct that for you. Right, so we have that function. And so we need to find the derivative. Again, if we don't remember how to do the power rule, that's what we're going to look at. From our sheet, it says that, well, we know first of all that we can do each part by itself because of the addition rule. This tells us that we can do each part by itself. And then, since we have a polynomial, the power rule is what we're going to use, where each one is going to be that power. We'll multiply it down front and remove 1 from it. So let's just go through doing that. So this is going to be 3 times 3t squared minus 4 times 2t plus 2. We've done this enough to realize that this turns out to be 1, and we end up with a 0 over here. So we'll simplify that. That v of t, which is x prime of t, I'm going to go ahead and keep that just so we keep those. That it's the derivative of x is 9t squared minus 8t plus 2. We then remember that acceleration is the derivative of the velocity, which means it must be the second derivative of position. And so the acceleration, I'm going to use the same thing. I have a polynomial, so I can do each term on its own. I just need to bring down the power and subtract 1 from it. So this is going to be 9 times 2t minus 8 times 1. And my constant term is going to go away. And so I get the acceleration is just 18t minus 8. And then I make sure to double underline my final answers. And we'll move on to part B. Part B, x of t is sine of 2 pi times t. And just to be clear, that part's in parentheses. That's all being taken the sine of. So my velocity is going to be the derivative of that. We haven't worked with a sine function yet. I can look on here on trig functions, and it tells me about what to do with just sine of x, but it doesn't tell me how I deal with the fact that I actually have a function inside there. So I actually have to combine that with the chain rule. And so chain rule is something we haven't discussed yet. The chain rule says that if I have a function g inside a function, then it's the derivative of that is the same as taking the derivative of the function times the derivative of what's inside. So let's see what would that. So if I'm going to use the chain rule, then my outer function f of x would be the sine function, and my inner function would be g of x, because I've got a sine with 2 pi would be 2 pi t inside of it. So the chain rule tells me that my derivative would tell me that I need to take the derivative of f of x. So that's where I can use the derivative of sine x is cosine x. So whatever I have, it's going to involve cosine x of what's inside there now. And it's going to take the derivative. I need the derivative of this, which will just end up being 2 pi. So my actual value here for v of t, which is the first derivative of position, is going to be, it tells me that it is, take my function, take the derivative of the outer function, so I'm going to do cosine, and what goes inside there is still my original function, so it's cosine of 2 pi t multiplied by g, by the derivative of g, so it's times 2 pi. So the chain rule tells me that I can take the derivative of something inside there. I just have to take the derivative like normal. Then I have to multiply by the derivative of what's inside. And if I flipped over to the other side of my sheet, I would find that for these simple sine and cosine functions, they have done that for me before. That if I had sine of omega t, that the derivative is omega times the cosine of omega t. So that omega t would be my 2 pi in this case. So it works out to be the same way. And I would want to rewrite this in a little bit simpler terms, that v of t is equal to 2 pi times the cosine of 2 pi t. All right, so that gets me the velocity, and I could double underline that. And then I still have to go another step and get the acceleration. So again, if I'm going to do this, I'll keep the 2 pi as a constant out front. This time my function is cosine. So when I take the derivative of cosine, the derivative of cosine is negative sine. So this is going to be negative sine of 2 pi t. And then I have to multiply by the derivative of what's inside, the 2 pi again. So that's just staying from there. This is my outside. This is my inside. And then I would simplify that again and get that a of t is negative 2 pi times 2 pi is 4 pi squared, so negative 4 pi squared times the sine of 2 pi t. So straighten that up for you. Sorry. So yeah, the acceleration, which is again still the same as the second derivative of my position, I actually get negative 4 pi squared over sine 2 pi t. And so it gets a little bit complicated. If I kept going, each time I would end up bringing out a 2 pi. I would take this derivative of what's in here, so it would go from sine back to cosine, and so on, and keep changing back and forth. All right, so part C, if we remember from up top, x of t was 20 cosine of 3 pi t minus 5t squared. So again, I got to just take the derivative of each part as it were by itself. So if I take the derivative of this cosine function, as we just learned by doing it in the previous example, it's going to be 20. I'm going to end up bringing the 3 pi out front as the derivative of what's inside. And then if I take the derivative of cosine, I get negative sine, and I have to keep what's inside there in there. So that's the derivative of the first term. The second term, a little bit easier. I'm going to multiply down by 2 and decrease the power by 1, so I end up with that. So v of t is going to be negative 60 pi times sine of 3 pi t minus 10 times t. And then I can get the acceleration, sorry, is the derivative of that. So the same sort of way, if I'm taking derivative of sine, I'm going to multiply that 3 pi out there again, so I'll get negative 60 pi times 3 pi. Derivative of sine is positive cosine. Derivative of 10t is 10. So a of t is negative 180 pi squared cosine of 3 pi t minus 10. And those are my two answers for part C. So each little bit we increase difficulty by a little bit. We learned about doing trig functions. We learned about the chain rule. And so we have those things going on, which should help us with future problems.